Bright Tuty. Every student matters.
Okay, so now this is pretty simple question for you. You just need to find the distance between following pairs of points. So the distance will be equal to 4 minus 2 squared plus 1 minus 3 squared. 4 minus 2 is 2, 2 squared is 4, 1 minus 3 is minus 2 squared is again 4. So 4 plus 4 is 8. So 8 can be written as 2 root 2, right? So this is how you calculate the distance. In this question, distance will be equal to minus 1. Now this is minus 5, right? So minus of minus 5 squared plus 3 minus 7 squared. So minus of minus 5 is plus 5, 5 minus 1 is 4, 4 squared plus 3 minus 7 is minus 4, minus 4 squared is again plus 4 squared, right? So this is 16 plus 16. This can be written as 4 root 2, right? 16 plus 16 is nothing but 2 into 16, right? This 16 can be taken out as 4, so 4 root 2, right? So this is the distance. These two coordinates are given in A and B. So again the concept is same. Difference of abscissa, A minus A squared. Difference of ordinates minus B squared. So it will be equal to, this is 2A whole square. This is 2B whole square, right? So this will be equal to 4A square plus 4B square. 4 can be taken as common and brought outside as 2 square root of A square plus B square. So this is your answer for this question, right? Find the distance between points 0, 0 and 36, 15. Again, you know that distance from origin is nothing but, let's say this distance is D. Okay, so how much is D? D is nothing but 36 squared plus 15 squared, right? The calculation part you can do yourself, or let's calculate. 15 squared is 225. What is 36 squared? 36 squared can be calculated like this. It is good that you memorize these squares, otherwise you can write as 30 plus 6 squared. So which will be 900 plus 36 plus 360, right? So it is 1260, 1296, right? You can memorize the squares up to 50 square, right? Otherwise you can calculate it like this. Okay, so when you add this, you'll get 1, 15, 21, right? So this is the distance between these two points, and now he's talking about distance between two towns A and B. Let's say this is town A, this is town B. So this is the distance between these two towns, right? Determine if the points are collinear. You know the test of collinearity. Let's say this is point A, this is point B, this is point C, right? You calculate the distance AB, distance BC and distance AC, right? If sum of any two distances is equal to the third distance, then we can say that these points are collinear. So let's calculate what is AB. What is distance AB? 2 minus 1 squared, which is equal to 1 square. 3 minus 5 squared, which is equal to minus 2 square, which is equal to 4, right? So root 5. What is BC? BC is difference of abscissa, minus 2 minus 4 squared 16 plus difference of ordinates, minus 11 minus 3 minus 14. Minus 14 squared is how much? 196. 14 squared is 196. So it will be equal to 206, 212 square root, right? Third distance AC, How much is AC? Difference of FCC, minus 2 minus 1 is 3 squared 9, right? Don't get confused in it. Difference doesn't have anything to do with the sign, right? Minus 2 and 1, what is the difference? Difference is 3, right? You won't say minus 3, because where is, let's say this is the number line, right? Where is 1? This is 1. Where is minus 2? This is minus 2. If I ask what is the difference, this much is the difference, right? What is this? 1 2 3, 3 steps, right? So minus 2 minus 1 is minus 3, or you can say 3 as a difference, right? Because you need to square it. Minus 3 squared is equal to 3 squared, so it is equal to 9. So minus 11 minus 5 is 16 squared, right? 16 squared is 256. So it will give you root of, this can be written as 265, right? For these points to be collinear, the sum of AB plus BC should be equal to AC, but you see root 5 plus root 212 is not equal to root of 265. It is not equal, right? Why is it not equal? You can calculate the approximate values, that number one, right? The second thing you can say is that when you do a square root of these are irrational numbers, right? So you won't get the perfect value for these square roots. So there is no question of being equal, right? So these distances are not equal. So these points are not collinear, right? So again you take these points at A, B, C and D, right, and calculate distances AB, BC, CD and AD first, and then if these distances are equal, then you can move on to calculate the distances of the diagonals, that is AC and BD, right? So let's do it very fast. AB 3 square 9, 1 square 1 root is root 10. BC 4 7 3 square 9, 6 minus 3 3 9, so root 18, 3 root 2. Distance CD 4 minus 1 is 3 squared 9, 3 minus 1 is 3 minus 2 is 1 squared 1 root 10. AD 4 minus 1 is 3 squared 9, 5 minus 2 is 3 squared 9, so 3 root 2 again. So you see, if I make a quadrilateral like this, AB, CD, AB is root 10, BC is 3 root 2, CD is root 10, AD is 3 root 2. So the opposite sides are equal. Opposite sides are equal. Hence we can say this is a parallelogram, right? If the opposite sides are equal, we can say this is a parallelogram. Now we need to check the diagonals, right? It is clearly a parallelogram, but if the diagonals are also equal, then we will say that it is a rectangle, right? So let's check the diagonal first before commenting the final answer. AC is how much? 4 minus 4 0 squared, 3 minus 5 2 squared, right? So it is equal to square root of 4, which is equal to 2. BD is 1 minus 4, sorry, BD 7 minus 1 6 squared, 6 minus 2 4 squared. So diagonals are clearly not equal, right? So we can say that this quadrilateral is a parallelogram, right? Okay, let's do this question. Find the point on x-axis. So any point on x-axis will be of the form x comma 0, right? On any point on the x-axis will have y coordinate as 0, right? So let's consider this is the point. Now this is equidistant from these 2 points. What are these 2 points? 2 minus 5 and minus 2 9. So these 2 distances are equal. So we need to equate these 2 distances, right? When these 2 distances are equal, their squares are also equal. So we can say x minus 2 square plus 0 minus 5, 0 minus minus 5, so 5 square is equal to x plus 2 squared plus 0 minus 9 squared is 9 squared, right? And we have squared both sides. So you can open it like this: x square plus 4 minus 4x plus 25 is equal to x square plus 4 plus 4x plus 81. So x square is gone. This will become 8x on the right hand side. This is 85. So minus 60 minus 56, right? So when you divide minus 56 by 8, x will be equal to minus 7. So the point is minus 7 comma 0, right? There will be a lot of points on this line which are equidistant from these 2 points, but this point lies on x axis. So there is he is talking about a particular point. So we have taken that point as x comma 0, and then we just calculated these two distances and equated these two distances, right? So once we equate these distances, we will calculate x is equal to minus 7. So the point in question is minus 7 comma 0. So it lies on x axis, right? Find the value of y for which the distance between these 2 points is 10 units. This is another simple question. P, Q, 2 comma minus 3. This is 10 comma y, right? And this distance is 10 units. So you just have to apply the distance formula: 10 minus 2 squared plus y minus minus 3, which becomes plus 3 squared. Square root is equal to 10, right? When I square both sides and calculate this, this is 8 squared 64 plus y square plus 9 plus 6y, right? And I squared this, so remove this radical sign and write 100 here, right? So now y square plus 6y, and how much is this? 64 plus 9 is equal to 73 equals 100. So y square plus 6y minus what? How much is 100 minus 73? It is equal to 27. So minus 27 equals 0. Now you need to factorize this, which is very simple. 9y minus 3y minus 27 equal to 0. So y plus 9 minus 3 y plus 9 equal to 0. The factorization thing we have done in quadratic equations lecture, right? So y will be either 3 or minus 9, right? So what is the value? Find the values of y for which the distance between these 2 points is 10 units. So we have got two values of y, 3 and minus 9, for which the distance between P and Q will be 10 units, right? If Q is equidistant from these two, find values of x and also find distances these. Let's say this point is Q, 0, 1. It is equidistant from P and R. It is equidistant from P and R. So let's take P and R first. Let's take P and R first. Let's say this is point P, 5 comma minus 3, and this is R, x comma 6, right? And point Q, which is 0 comma 1, is equidistant. So these distances are equal. Distance PQ is equal to distance QR, right? So let's apply distance formula here. PQ is how much? Square root of 0 minus 5, 5 square. 1 minus minus 3 is 4 squared. 25 plus 16 is equal to square root of 41, right? What is QR? QR is x minus 0, x square. 6 minus 1, 5 square. This is equal to 25 plus x square, square root, right? Now it is given that PQ and QR are equal. So it is pretty obvious that x square is equal to 16. So x will be equal to how much? Plus minus 4, or what you can do is PQ is given as equal to QR, right? So PQ square will be equal to QR square, squaring both sides. What is PQ square? PQ square is 41. What is QR square? It is equal to 25 plus X square. So this implies X square is equal to 16. So X will be equal to plus minus 4. So we have got two values for X for which this condition satisfies. Now we need to calculate distances QR and PR, right? So once you take X as plus 4 and once you consider R as 4 6 and once you will consider R as minus 4 comma 6, right? And you need to calculate QR and PR. What is Q? Q is 0 1 and what is P? P is 5 comma minus 3. Q is 0 comma 1. P is 5 comma minus 3. So PR and QR. PR and QR. What will be PR here? In this case, this is second case, right? So let's divide the page like this. What will be PR in this case? It will be 5 minus 4, 1 squared is 1. Minus 3 minus 6 is minus 9 squared, 81 square root. So square root of 82. What will be QR? 0 minus 4 square 16. 1 minus 6, 5 squared 25. So it will be equal to 41 square root. This is PR and QR in this case. When you consider negative value of X minus 4, right? So what will be PR? PR will be 5 minus minus 4, 9 squared 81 plus minus 3 minus 6 minus 9 squared 81. So square root of 162. And how much will be QR? QR will be 0 minus minus 4, 4 square, 1 minus 6, 5 square. So it will be equal to 16 plus 25, 41 square root. QR is same in both the cases, PR is different, right? So we have got these answers. This is your final answer. Let's do one more question in this exercise. Find a relation between X and Y such that XY is equidistant from these 2 points. What are these 2 points? These are 3 6 minus 3 4 and this point, let's say this point is P XY, it is equidistant from these two. This distance is equal to this distance. So let's equate these distances. PA is equal to PB. So you can say PA square is equal to PB square. Apply the distance formula. What is PA square? X minus 3 square plus Y minus 6 square. It is equal to X, this is minus 3. So X plus 3 square, Y minus 4 square. Right? We just need to equate these and we will get the desired relation. So let's open these brackets. X square plus 9 minus 6x, Y square plus 36 minus 12y equals X square plus 9 plus 6x, right? Plus Y square plus 16 minus 8y. X square and Y square, X square and Y square gone. Okay, let's look at X. 6x and this minus 6x will become 12x. Minus 8y and this minus 12y will come on right hand side as plus 12y. 12y minus 8y is plus 4y, right? So these two terms are calculated. These two are already calculated. 16 plus 9 is 25. So this 9 you can cancel here, right? So you just need to subtract 36 minus 16, which is 20, right? So now you see that this equation is divisible by 4 on both sides. So divide it by 4 on both sides. 5 is equal to 3x plus y. This is x. 3x plus y is equal to 5 is the required relation in x and y, right? So this was about this exercise, right, on distance formula basically. So we discussed the basic concepts of coordinate geometry in this exercise and usages of distance formula, right? So in the next exercise we will talk about section formula, where we will divide a particular line segment in two parts, in two ratios, and then calculate those ratios. If the ratio is given, we will calculate the coordinates of the point. So we will meet in the next lecture. For this lecture, thank you.